Now that we've kind of really established what derivatives are, we're going to talk about different properties that come up that are kind of random, but also very important when we start talking about derivatives. So to differentiate a function, it must be smooth and continuous. So smooth means that there are no sharp corners, which are places where the derivative is undefined. So for example, if you have a function like this, you've got a sharp corner right here, and so the derivative would be undefined, and you can't differentiate this function at that point. You can differentiate over this whole section because this is smooth, there's no sharp bits. And you could differentiate over this section because there's no sharp bits, but you can't do it there. This would be smooth because you'll notice there's no sharp corners, generally speaking. There's also a weird edge case that technically if I go vertical, that doesn't work because the rate of change here will be infinite, and that's not a, now that doesn't violate smoothness exactly. It's kind of a weird nebulous area there. But the main thing here is we want to see no sharp corners. So the derivative properties, anytime you have a discontinuity, that will cause a derivative to be undefined. So if there's a discontinuity, by definition, that function is undefined. And this is because for a jump discontinuity, the slope is undefined at the jump. Because if you look at it, you'll have something like this, and we go from here to here. Even if the slope is the same before and after, here at this point we have a jump from some y value to some other y value with no change in x. And so we have this infinite jump, and there's no way to have like a slope, there's no way to have an average rate of change there. Infinite discontinuities, the rate goes to infinity. So the plus or minus infinity. And therefore, the derivative is undefined because it's approaching infinity. And then with a removable discontinuity, either the function is undefined, which means it's not continuous and therefore it can't be differentiable, or it has a jump, which gives us the same problem as a jump discontinuity. So if I just have something like this, this is not differentiable at this point here because we don't have a defined value here, so we can't find the average rate of change, right? Remember that, or not the average rate of change, we can't find the instantaneous rate of change because it involves, when we looked at that definition, this function right here, or this equation. So if f of x doesn't exist, we can't do this. Or it's got some f of x here, in which case we've got a jump, and that's going to give us weird infinite results as we get closer and closer to our point. So any sort of discontinuity messes this up, which means that differentiable, aka all differentiable functions are continuous. So if we say a function is differentiable, it is by definition continuous. If it's continuous, it may be differentiable, but a continuous function can have sharp corners and therefore may not be differentiable in some cases.